Welcome to the SourceCon 2022. I'm Peter Foldhazi Jr., and I've been working for EPAM Systems for almost 10 years now. And during this time, I was mostly a software test automation engineer. And most recently, I started working as a consultant in the United States, focusing on mostly test automation projects, but anything that relates to quality and testing. And today, I would like to talk about uh, different design patterns. First, giving some basic knowledge about design patterns because I'm aware that not all of you might know what the design patterns are or may not know them extensively. And maybe I can give some interesting information for those who are already aware of some of the design patterns. Then the two main topics will follow: the page object and the flow model pattern, and how you can incorporate it both in UI and in API, and actually end-to-end testing as well. So that said, let's get started. So whenever someone talks about design patterns, I believe that most people who have heard this term before will think about the gang of four design patterns for very, very good reason. And I believe as we test automation engineers are developers as well, we need to be aware of the design patterns. And I don't think we need to know all of these 23 different design patterns, but it's really useful to get accustomed with some of them, start using them in our projects, some of these design patterns, because they definitely are helpful in improving our code, making them uh, cleaner and more maintainable, and so on. My personal favorite is the facet pattern, and there are numerous reasons for that. First of all, I think this can be easily leveraged in test automation. And second, the page object pattern, the flow model pattern, and many other test automation specific design patterns are actually built on the facet pattern. So what it is? So basically, you're literally creating a facet over a piece of code that you would like to hide. That's not because you want to make it a secret or anything like that. You just don't necessarily want to expose it to others because they are not really interested in the implementation details. They just want to use that service. For example, in this example as well. But more to that later when I will deep dive with the founder pattern. And as I mentioned, a couple of test automation specific design patterns are leveraging the facet pattern. And the first one is the page object. And the inventor of that is Simon Stewart, who is actually literally speaking at the very same time as I am right now on the very same conference. So that's a huge honor for me to be speaking basically parallelly with him, who invented the page object that is the basis of the flow model and the screenplay and the UI objects as well. So we can thank him a lot, uh, seriously. So uh, how they differ, these different models, is that the first one, the page object, focuses on how you organize your pages. The screenplay, which is leveraged in the Serenity BDD primarily, focusing on how you organize your users. The flow model focusing on how you organize your user actions. And lastly, the UI objects focuses on how you operate your pages. So each of these are answering a little bit of different questions, and basically you could even combine all four of these and have an even better test automation solution. More to that later. Before that, I would like to go deeper into one of the main topics of today, and that's, of course, the page object pattern. So when you look at this piece of code, then what do you think first? What are the first thoughts that come into your mind? N- Are you able to immediately figure out what this test script does? Like, first of all, is it a test script? And then what exactly is happening here? So you will definitely need a couple of seconds, maybe half a minute before you can figure out what's happening here, what are the exact steps that are being executed here. And eventually you will see that this is actually a login scenario for a successful login. So of course, this is working. This is all good from that point of view, but there are numerous issues with this code. First of all, not just like the readability, but also maintainability, scalability as well. And in the long run, this is something that you won't really be able to keep maintaining, especially once you have dozens, even hundreds or thousands of test cases, you won't even get there. So whenever I see someone coming up with such unrestricted script in uh, unstructured script in 2022, that's how I look like. And the first ever like design pattern that was revolving around solving these kind of issues was the page object model. And basically what it does is that you have different before I go on. So you should be thinking of web UIs, right? Or mobile UIs. It doesn't matter if it's mobile or web page or desktop, but you do have pages, you have a UI to interact with. And when you do, you have all sorts of different buttons, edit text, speakers, images, and so on. So you want to make sure that you are able to go through a certain user test, be able to validate the controls of each of the pages, and you are going to create a class file for each of these pages that you are going to interact with, and each of the elements that you are going to interact with. So what it does, whenever you have to hit a certain button 50 different times, you're not going to write down how you find that, how you locate that element, how you interact with that. You just do it at one place. So because of that, if there's any changes in how you locate that certain element, you only have to change it at one place instead of 50 different places. Now, I think that's a pretty big win. And before going on with some of some more details about the page object, I just want to make sure that you see what the history of the page object is, because it's very difficult to find it now. Back in the days, there were a little bit more on the internet. For some reason, they were lost, but Simon Stewart was very helpful and gave me some insights of what was going on at the beginning of the 2000s, even at the end of the 90s. So at one time he was working in the Works, which some of you might be familiar because of Martin Fowler, who works there and is one of the big brains over there. And actually Simon said that Martin definitely had a huge influence on the page object, on Selenium as well. And so you can read all the details here. Most important, I think, is that it was 2007 once Simon had his first public speech about the WebDriver and the page object as well. So that's when the word really got out and people really started uh, leveraging both of these. And so, of course, as test automation engineers, we always try to make things easier to use, more advanced, and we always have a lot of discussions on how we can improve design patterns, principles, how you can improve a piece of code. And there were some people who were saying that the page object pattern is breaking the single responsibility, the open closed as well, and the Yagni principle as well. I myself actually would debate that, and I believe that it's only the single responsibility that is being broken. But we can discuss that in the Q&A if you want. Regarding the Yagni, I just want to mention that part that you're never going to need it part. It's all up to the test automation engineer itself and the tester itself, like how you design your test cases. So why people were saying that this page object is breaking that is because if you have a page and you write down all the locators and all the elements, then most of them you're not going to even exercise them in your tests. But why would you do that? That's not because of the page object, that's because of you. So if you start creating your test cases first and then creating your page models and the web elements and the locators, the ones that you are actually using in your test cases, then you're only going to use the ones that you're only going to define the ones that you're actually using. Okay, so going onwards with the single responsibility. So what is that exactly? In a nutshell, you can see on the left side three different shapes in one pack. On the right side, you see three different shapes, these very same different shapes in separate columns, let's just say that. And basically, in the left one, where everything is in one place, it represents that you have a class file with these three shapes. And so whenever you make a change, you want to make a change, let's say, in the circle, then that will mean that you might potentially make a change in all the other shapes as well. And so you can introduce bugs in other features of your application. And so a good way to evade that is if you separate them into three different class files. So you have a separate triangle, you have a separate rectangle and a separate circle class files. And now whenever I'm going to make a change in the circle, it's never going to affect the other two shapes. Of course, these are very simple examples. So you might not see as much complexity here as with a class file which has more than 10,000 lines of code, or maybe even 15 or 20,000. Remember the view class of Android? Yeah, now we're talking about it. Okay, so that said, the page object is breaking the single responsibility in the form of having all the locators and web elements and the user actions and user flows in one place. Let me show you how. And before we can identify that, there's one thing that Uncle Bob mentioned about the single responsibility. He's the one who invented it. And when he was asked about like, okay, how can I determine what are the different responsibilities? How many responsibilities a certain method or class file has? And so he said that it was a little bit difficult to explain it well to the people, but eventually he had a very good idea how to explain it best. And that's basically the responsibility comes from the people. So you have to determine how many people will affect your method or class file. And in the case of the page object, I believe that it's two different groups of people. So the locators elements are dependent on how the developers are implementing the actual product. Whereas the actions and user flows are either coming from the business people or from the testers, depending on your organization. But I believe in an ideal world, they should actually come directly from testers and, of course, uh, business analysts or product owners may have their impacts on it as well. So that still means there are two reasons for change. So there are at least two responsibilities for the page models. And as I again, like, let me reiterate what I said before. So the page object breaks the single responsibility. Some say it breaks the open, closed, and the YAGNI. I don't agree with those two parts. The page factory also, let's mention that it's not recommended anymore, and unfortunately, still a lot of people are leveraging that. So if you are a test automation engineer and you want to go to the next level inside your company, or you want to interview to another company, make sure you remember these things because some of us might ask these questions. I think these are very important for test automation engineers to know. And let me have a little bit of water break. And we are halfway through the presentation. So it's about time I talk about the main topic, the flow model pattern. So you can see two houses on this slide. The one on the left side is represented in the page object pattern. So there you have a facet that includes all the pages, widgets, user actions, user flow, so the locators and elements of these pages and widgets. So basically, you have in each of the models, you are storing all of these there. Instead of sizing them up, just like how it's in the flow model pattern, you have basically a facet over facet. So how does it look like? So you have page and widget models, and above them, as another layer or another facet, you can find the user flows that store all the user actions and user flows. Okay, so how does that look like with some other examples? Let me first give you a UML state machine diagram example. The reason is that I believe the flow model itself can be most easily described with a state machine diagram. So on this example, you see a soda state machine. And so you want like to get a drink, you select from the list of drinks, you make payment, and you get to the confirmation. So there are different, in a state machine diagram, there are states, and from one state to another, you can get by with a transition. That's it. So you either have a state or a transition. And so in a flow model design, this is how it looks like. Your states are the actual screens or pages that you are on. So you are right now on the main screen. Then how you can get to the login screen is clicking on the login button as an example. Now you're on the login screen. So you can type in your credentials and you're going to stick to that very same page. You're still on the login screen, and once you type your credentials correctly, click on the login button, then you land on your profile screen. That's where you can make some leads, get to some other pages as well. And then eventually, if you click logout, you get back to the main screen. So that's how the flow model can be best described. Now, with a little bit more spice to it, I added some widgets as well, and I'm talking about an Android application example in this case. So you are on that main screen, you have a toolbar widget where you can access the menu. So you create a toolbar widget and a menu widget for the toolbar and the menu as well. The reason is because the toolbar can be accessed from different pages as well, and it's still the same toolbar, or most of the time it's the same or very similar. Menu, same thing with that. You can access it from all pages or almost all of the pages, and it's always going to have the same contact or supposedly the same contact. And because of that, you're not going to stick it to one screen. You're always going to have it separate. Okay, so how does the flow model um, look like in a test automation architecture? Where do you put it? Where do you place it? So if you're leveraging a tri-layer architecture where you have test scripts, business logic, and the core libraries that are common libraries basically, then you should have it somewhere in between in the business logic because they are the ones that are really defining like how your pages look like and what are the user actions that you are doing on those pages. And that's what the test scripts are going to call from. See, so the flow structure models are providing services for the flow models, and the flow models are providing services for the test cases themselves. And that said, I would like to go on and show some examples, coding examples too. So you can see a trial layer architecture here once again with now just one test case. I don't want to show a whole solution, just a little bit of it. So inside, as I mentioned before, you shouldn't be writing your elements and logators first and the user actions first, and then writing the test cases after that, because you might implement uh, things that you don't really need. So first you need to write your login test and start creating your structure and flow models. That's how I like to implement my test automation solutions. So let me show you how that looks like. You might remember this piece of code from the beginning of this presentation, and let's make it a little bit tidier and tinier as well. So there are no page models, no flow models leveraged in this solution. So first thing what I will do is creating the page or screen structures. Why I call them differently is page. I like to use the term page uh, models or page structures when I'm doing web UI testing. When it's mobile UI, I like to use the term screen structure. So I'm going to have all my elements here with their locators, and then from now on, whenever I do a refactoring, in my test case, now I will know where I am. So I already answered one question here, where I am right now. I'm on the toolbar, in the menu, on the login screen, and then eventually on the home screen. So see, it's already a much better test script. It's easier to realize what's happening in this test script. Let's go on to the next one. So the next one is when you start leveraging formulas. So you create methods for all the different user actions that you have. And now you're going to move the actual user actions in these methods. And you can see that the page models or screen models are already leveraged here. And then what you do is just simply rewriting your test case and now calling from the login flow. So what happens now, you as a tester might not be that, like you might not be, it might not be that important for you to see right away where you are, but what you are doing is much more important. So when you look at the test script, you see step by step what you are doing. It's a login flow. You see that it's a very simple test case only with one flow, and you open the side menu, open the login screen, type your username Darth Vader and your password, I am your father, and eventually once you logged in, validate whether you were logged in as Darth Vader. That's it. And if you look at the comparisons, on the right side you can see the unstructured one, on the bottom left when you leverage the page model, and on the top left when you start leveraging flow models as well. So in my opinion, the one on the top left is much easier to understand and easier to maintain. But you're the judge, so I hope that you like it and you will be able to leverage the flow model as well in your test automation solutions. Next up is the flow model pattern for end-to-end and API testing. So when we talk about API testing now, I'm focusing on that primarily. There's no UI, no screen and page models, obviously. So that means instead of that, you have utility classes. For each of the API, DB calls, Splunk validations, whatever you are leveraging in your end-to-end scenarios. And again, it's very important. So we are doing end-to-end testing on API on service level, so no UI at all. It's also very important to mention that if you want to leverage the flow model for atomic API test cases, it's not going to work. So I wouldn't recommend that. It's frivolous. So let's see an example. And first, you might remember the business logic from the tri-layer testing architecture that I mentioned before. And I mentioned that instead of the structure models, now you should be leveraging utility classes. So that's the only real difference here. So uh, let me give you an example, suspension flow. Let's say that you want to validate that you have a bank card. You want to make a transaction, but before that, there's a suspension. For whatever reason, the card gets suspended. So once you do the transaction, then it's going to fail. So you want to see whether if it can be unsuspended correctly or not. So you unsuspend it, you do the transaction again, and now you validate whether the transaction will go through or not. So how that piece of code is going to look like here. Now a big difference to the compared to the previous example is that now it's not just one flow model that is being leveraged, but a couple of those. And so first you, of course, log in with the active user and valid card. You make the suspension, validate the suspension, then you do the transaction, validating that, then you unsuspend the card, validate the unsuspension, make the transaction, now it's a valid one, and then you can validate that the balance actually decreased. So what the flow model provides is obviously in the test case, you don't necessarily want to see all the details how you validate the suspension, but you can have all of that here. And these are actually also more detailed suspensions. So you're not going to make just one line of code of suspension. You might make, especially in DB, you may check a couple of records. So to summarize it, the flow model provides a solution for the single responsibility by slicing up the page objects into page objects or structured models and flow models, separating the concerns of the application structure and the business logic. The facet pattern is leveraged here not just once but twice, providing a facet over the facet and making a higher, like creating higher abstraction. And in my experience, as I've been using this since 2013, it provides easier ramp up for newcomers and especially junior developers or junior test automation engineers, lower maintenance costs, and compared to the page object, it can be leveraged not just in the UI, but also in end-to-end API testing. Now, the big negative part is the experience that it's experience based. So you need to be a very experienced tester, not just a test automation engineer, but also very experienced tester to be able to easily create flow models. Or you need someone in your project who has a huge domain experience and can create the test cases for you and also the flow models. So this way you only have to learn from that person and do the implementation yourself. So I would like to thank you for having listened to my presentation, and I hope you are enjoying the SourceCon 2022. And please leave your messages and ask me any questions. And not just here, but you can find me on Twitter, on LinkedIn as well. You can find my other presentations on YouTube. And actually, most recently, I created my own website, so you will be able to see some of my articles there and any news about where I'm going to speak next. So thanks again for being here with me, and enjoy the rest of the conference.